Alright, so first, 70% of 328 million. Let's first start by looking at 1 million. Finding 70% of that. 70% of that would be 70 million. And take, if you think, out of 100, 70%, kind of just look at that. So then add on all the extra zeros. Now we know there's 3 million, so we got to do this 3 times. That's going to be 210 million. So that's just of 300 million. Now we have this 28 million left over. If I was to estimate it, I'd say, well, 3/4 cut 28, because 70% is about 75%. So if we cut 28 into 4 pieces, that's 7 each. 3/4 would be 21. So it's going to be a little less than 21 million. So let's just estimate it to be about 20 million. So we need to take our 2 pieces and put them together. That would be about 230 million. Okay, so that would be our final estimate. You don't have to estimate the same way, but it's the same idea. So if 70% of the United States is getting coronavirus, that's about 230 million people. Now looking back here at our graph for the United States, is this linear or nonlinear? It goes and it goes up like a curve. Clearly this is non-linear. This is actually exponential growth. You'll learn about that a lot in Algebra 1. Now what's tricky to know is, are we slowing down the rate of change, that curve, or not? Which is why this gentleman, Atash Bhatia, made this graph, which is a proportion of the new confirmed cases in the past week with total confirmed cases. This actually makes that exponential curve more linear. There's a pretty cool YouTube video that I'm linking in the comments that talk about how do we know when we're breaking the curve, and that's when we fall off of this line as well. So this is linear. This graph was nonlinear.